In order to use parameter optimization methods, we first need a model to optimize. Thus we create a new model. We add 2 resistors, 1 ground, and finally a DC voltage source. We make all the connections in our model. Now we set the DC voltage source voltage to 100 volts, resistor 1's resistance to 60 ohms, resistor 2 shall remain at its default value. Since the model is complete, it is now time to define our optimization problem. We need to calculate the resistance of resistor 2 for this system to work at maximum power. Let us click the optimization tab from the toolbar at the top. When we click the cost function button in the lower toolbar, we will be asked to enter the cost or objective function. We first create a text file on our desktop. Note that the file should have a .py extension. Right-click and edit with your favorite text editor. Here we define our objective function. Resistance of resistor 2 will be the argument to this function. Power consumption of the circuit shall be the output of the objective function. Thus we write the mathematical expression of Joule's law. Once our objective function is defined, we can return back to FlowNetMaster. Click on the cost function button on the top left again. In the window that opens, click on the button on the side to select the file with the .py extension that we have just created on the desktop and select our file from the window that opens. We enter the name of our function from the file name section, then we click OK and close this window. You will see that the optimization button on the right hand side of the cost function has become active. We click on this optimization button. We choose random search from the methods section. Note that for high-dimensional problems, random search algorithm can become quite inefficient, as it is a brute force algorithm like the grid search algorithm. We can rank our results from high to low or vice versa by choosing one of either maximization or minimization options. We then determine the number of random search points. We choose resistor 2 resistance in the parameters. We also enter the minimum and maximum values for resistor 2 resistance. Random values will be picked between these bounds. Click on the Run button to execute the model for each point in the random parameter space. When the solution is finished, we click on the button on the right hand side as shown in the screen. We can see and sort the results in the expanding window. FlowNetMaster, digital twins made easy.